Welcome to EC Electronics. This is a preparation video for HSFC Technical Assistant examination, and we are going to see the previous year questions of HSFC Technical Assistant examination of 2011. Okay, so here the questions are in this question paper. The questions are more numerical based. Okay, so if you are preparing for any locations technical assistant examination, this video will be useful for you because most of you guys are requesting to do numerical questions. Okay, so this question paper discussion will be very much useful for you. Okay, so the first question is the channel capacity under the Gaussian noise environment for a discrete memoryless channel with a bandwidth of 4 megahertz and SNR of 31 is dash. Okay, so this question is asking the channel capacity. So when you are seeing the bandwidth and the SNR, you can always think of the equation which gives the channel capacity of a channel with particular noise. That is, here it is Gaussian noise. The equation or the relation is called Shannon-Hartley theorem. We have discussed about this equation or this theorem in various videos. And the equation is giving the maximum channel capacity of a that is possible for a channel under the presence of certain noise. Okay, and C, which is the channel capacity, is given by B into log 2 1 plus SNR. Okay, this is the equation. And if C is the channel capacity, then you have to always select the data rate R, which is less than or equal to the channel capacity in order to have a error-free transmission. That is, whenever we are sending some data, you have to select a data rate which is R less than or equal to the maximum channel capacity. Otherwise, which will lead to error. Since the channel is a errorful channel, it can have errors. So the maximum channel capacity without error-free or error-free transmission is given by C is equal to B log 2 1 plus SNR. Okay, so I'm going to apply the equation in this equation directly because I have the value for bandwidth. So it is 4 megahertz into log 2 1 plus SNR, which is 31. Okay, so this is the equation. And if you solve it, you will get the value as 20 megabits per second will be the channel capacity obtaining. Okay, so the correct answer obtaining is 20 megabits per second is the answer. Question is this. In an amplitude modulated system, the total power is 600 watts. The carrier power is 400 watts. Modulation index. Very, very direct question. The equation using is a famous equation for the total power of a AM modulated system. PT is equal to PC into 1 plus M square by 2. Where PT is the total power of a AM system. PC is the power offered by the carrier. Into 1 plus M square, where M is the modulation index. So here in this question we have been given PT and PC. We need to find the value of M. Okay, so directly we can apply. The total power is 600. We have used this equation again in lot of previous year question paper discussion. So while you are discussing these questions, when you are discussing more and more question papers, you will get thorough with these typical questions. See, some questions will be seen in all question papers. These questions you will get familiarized with. Okay, 600 watt is equal to 400 into 1 plus M square by 2 is the equation, and if you solve it, you will get the value as M is equal to plus or minus 1. You will select only positive values for modulation index. So the value of modulation index obtained after solving this relation is M is equal to 1 is the value of modulation index. Moving on to the next question. A microprocessor has 12-bit address bus, will be able to access dash kilobytes of memory. Okay, so how to solve it? It is a 12-bit address bus. 12-bit address bus. So you can split this 12 as 10 plus 2. That is 2 raised to 10 into 2 raised to 2 kilobytes. Right, this much of memory it can access. 2 raised to 10 is called kilo in binary number system into 2 raised to 2 is 4. Okay, so you can write it as 4 kilobytes of memory it can access. Okay, so the answer is 4 kilobytes of memory it can access. Okay, so the correct answer is 4 kb or 4 kilobytes. Next question, a practical current source is usually represented by dash. A practical current source, we generally, when representing ideal current sources, we only represent the source. But in practical, when we are representing a current source, we represent it as an ideal current source plus a resistor in parallel. This is how we represent current sources. And if it is a case of voltage sources, this is current source, right? And if it is voltage sources, that is if we represent a practical voltage source, then we represent the voltage source plus a resistor in series. This is how we represent voltage sources, which is practical. Practical voltage source will look like this and practical current source will look like this. This is ideal current source and this is ideal voltage source. So when we are talking about the ideal thing, we don't have to consider this internal resistance. But when we are talking about the practical case, we have to take into consideration about its internal resistance also. So that is why we represent for the case of current source, we represent a parallel resistance, and for the case of voltage source, we represent a series resistance. Okay, so this is how. So the correct answer for this question is a practical current source is usually represented by an ideal current source plus a resistor in parallel. Consider analog signal x of t is equal to 3 cos 100 pi t. If the signal is sampled at 200 Hz, the discrete time signal obtained will be dash. Okay. Options are A, 3 cos pi n by 4, B, 3 cos pi n by 2, C, 3 cos pi n, D, 3 cos pi n by 3. Okay. In general, we can represent an analog sinusoidal signal as A, consider the signal B, x of t. It is continuous in nature, so it is x of t is equal to A cos 2 pi f t plus theta, where A is the amplitude, 2 pi f is the frequency, t plus theta is the phase. Okay. So here there is no phase part, so we can ignore it. Now if we are going to, okay, I'll remove this. Now if I'm going to sample the signal means, I'm going to sample it with a frequency fs is equal to 200 Hz. I'm going to use it as, that is I'm going to use 200 Hz. So now I'm going to sample the signal with 200 Hz sampling frequency. So I'll be getting x of n, and the general equation for sampling or sampled signal is represented as, I'll write it as x of n. The general equation is x of n is equal to A, there is no change in the amplitude, cos 2 pi, you have to write f into n by, that is I'm going to change t to n by fs. This will be the sampled version where f is your original frequency, fs is this frequency, that is a sampling frequency. Okay, so for this question, I'm going to write first x of t. What is my x of t? It is 3 cos, there is inside this cosine there is 100 pi t. So you can write it as 2 pi into 50 t, right? That is, I have splitted it as 2 into 50, 100. So 2 into pi into 50 into t. Very simple. Sampling frequency fs is 200 Hz. So here you have to change this to 50 and n by 200, right? So this is all you have to do for converting a signal from continuous time domain to discrete time domain. That is simply sampling by the given sampling frequency. Okay, so what is the answer obtained here? A is 3. 3 cos 5 2s are 10, so it is a 2 in the denominator. 3 cos pi n by 2 will be the answer obtaining. Okay, so the answer obtaining will be 3 cos pi n by 2. From the options, the correct answer is option B, which is 3 cos pi n by 2. I hope this concept of sampling is clear. I'll explain it once again. X of t, that is a general equation or representation of the continuous time signal, if it is sinusoidal, is a cos 2 pi ft. So in order to convert that to the discrete domain, you will be getting x of n while discretizing or sampling. X of n is equal to 3 cos 2 pi f into n by the frequency of sampling, which is fs. Okay, I'll write it once again. This is the equation for converting or sampling the signal with a particular sampling frequency fs. Okay, so the correct answer for this question is option B, which is 3 cos pi n by 2. The dominant mode of rectangular waveguide is TE10 because it has dash. We select dominant modes based on the cutoff frequency. The modes with the highest cutoff frequency is kept as the dominant mode of each waveguide. That is for TE means there is only electric field, there is no magnetic field present. Okay. So you have to know about the dominant modes, that the dominant modes are modes with highest cutoff frequency, and for the case of this TE10 mode, there is only electrical field, there is no magnetic field. Okay. So the answer for this question is it has to have maximum cutoff frequency and it is not having magnetic field. From the options, the correct answer coming is it is having no magnetic field since it is the dominant mode. And also, if in the options it is given that it is because it is having highest cutoff frequency, then that is the apt answer for the question. Okay, moving on to the next question. In satellite communication, and also to talk about this equation, that I have done a separate video for the equations for these waveguides and all. I'll share that in the description box so that you can refer and gain more knowledge. Okay. So next question, in satellite communication, FM is used because dash, because it is having, that is FM means frequency modulation. In satellite communication, we go for frequency modulation because it is having maximum bandwidth and minimum noise. Okay. Answer is it is having maximum bandwidth and minimum noise is the correct answer. Minimum noise. Okay, so we know that for FM, the modulation index M is given by maximum frequency deviation by modulating frequency, right? So when the modulation index is increasing, the maximum frequency, they are having a direct proportionality. So the more maximum frequency deviation, this maximum frequency deviation you can also think of as maximum bandwidth. That is, this can also be same as bandwidth. Maximum frequency deviation means bandwidth. Okay. So when using FM or frequency modulation systems, they are having maximum bandwidth, also minimum noise. So that is apt for satellite communication. Next question. In VHDL, all statements inside process statement are dash. The options are concurrent, sequential, likewise. So I have given the general syntax of writing a process. So we have already started with the classes of VHDL. We have done the first part in which we have discussed about the entity architecture and everything. So this is about the process statement which we write in VHDL program. So in process, how we write the process, the syntax is like this. There is a label, process label, then process sensitivity list. Then there is a declaration part in which we declare any variables. Then begin. Then here sequential statements we write. Okay, so the correct answer is all statements inside the process statement are sequential in nature. They are not concurrent in nature. Okay. Then end process, process label. So I'll tell it once again. There is a process label. Then there is process. Its sensitivity list means the variables on which this process is actually depending. That is called its sensitivity list. Then there is a declaration part, begin. Then we write the sequential statements within the process. Then end process, process label. Okay, so the question is, in VHDL, all statements inside process statement are dash. They are sequential. Okay. A 12-bit ADC is operating with 1 microsecond clock period and total conversion time is 14 microsecond always. The ADC must be of dash type. So in this question, we have to take into consideration the total conversion time. The options given are flash ADC, counting type ADC, integrating ADC and successive approximation ADC. I have written here all the conversion time equations for all these ADCs. That is, for counting ADC, the total conversion time TC is equal to 2 raised to n minus 1 into T clock. That is, TC is a total conversion time where n is the number of bits of the ADC. For this question, it is a 12-bit ADC. So, n is 12. T clock is the time period of the system clock. Here it is 1 microsecond. So, if you calculate this, the conversion time obtaining is greater than that of 14 microsecond. So, this is not our answer. And for integrating type of ADC, the conversion time TC or maximum conversion time is equal to 2 into 2 raised to n by f clock. This you can write as into T clock also, because 1 by frequency is equal to time period, right? So, 2 into 2 raised to n into T clock will be the value of total conversion time. So, this equations are very, very important. Please note this down. For integrating type of ADC, conversion time is equal to 2 into 2 raised to n by f clock, that is frequency of operation, or into the time period of the clock. Then for the next option, which is successive approximation ADC, the conversion time TC is equal to n times T clock. Okay, so TC is a total conversion time, n is a number of bits, into T clock is the time period of the clock. So this also you will get as only 12 microseconds, because it is a 12-bit ADC, n is 12 and T clock is 1 microsecond. So it is, how much it is? 12 microseconds. So this is not also our answer. Also, if you calculate this, also this is not the answer. So the correct answer has to be flash ADC. The conversion time of flash ADC can go up to 14 microseconds. So this the correct answer for this question is flash ADC, and generally flash ADCs are actually designed to reduce the conversion time. But what happens is that after the number of bits of the ADC is greater than 8, it will won't work perfectly. Okay, so the conversion time will get increased after the size of or the bits of ADC is growing after 8. Okay. So for this question, from these options, the correct answer has to be flash ADC has to be the answer for this question, since the conversion time is not 12 and also not these answers. While you calculate by applying these equations, you won't get it as 14 microsecond. Okay, so the correct answer for this question is A, which is flash ADC. Next question is this: a PN junction is in series with 100 ohm resistor is forward biased so that the current of 100 milliampere flows. If voltage across the combination is instantly reversed to 10 volt at t is equal to 0, the reverse current flows the reverse current flows through the junction at t is equal to 0 is dash. Option A 0 milliampere, option B 200 milliampere, C 50 milliampere, D 100 milliampere. To do this question, so in order to do this question, first we will try to draw the figure. So there is a PN junction, there is a resistance in series, and there is some voltage applied. Okay, the value of this resistance is 100 ohm, and the current flowing through the circuit is 100 milliampere, and it is said that the potential or the voltage is instantaneously reversed to 10 volt. So the voltage is actually now 10 volt, and the polarity is being reversed. Okay, so this diode will be in the reverse condition, and there is some reverse current flowing through this diode. We need to find the value of that reverse current. Okay, so what happens when the polarity is being reversed? The diode will actually act as a short circuit. Okay, so when the polarity is reversed, it will act as a short circuit now, and the current flowing through this short circuit will be equal to the current flowing through the resistor. So simply, in order to find the current in the reverse condition or reverse current, we need to find the value of current flowing through the resistor in the reverse condition or when the polarity is being reversed. So during this reverse condition, current through PN junction is equal to current through resistor. So what is the current through the resistor? Voltage is 10 volt. The value of resistance is 100 ohm. So I is equal to 10 by 100. It will be equal to 100 milliampere. Okay. So the current flowing through the resistance during the reverse condition is 100 milliampere, and that will be equal to the current flowing through the diode because it acts as a short circuit since the polarity is reversed. Okay, so the current will be equal for this resistor and this short circuit. So the current option or the current value obtaining is 100 milliampere is the correct answer, which is option D is the correct answer for this question. So these are the questions which I have included in this video. I hope that this video was useful for your preparation. This question paper consists of a lot of numerical videos which will be very much useful if you are preparing for any of the technical assistant or scientist examinations. So if you found this video useful for your preparation, please do give it a thumbs up and share this videos with a maximum of friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.